I am going to be discussing about differentiation. So, what is differentiation? Differentiation is a process to find derivative or rate of change for a function. It is also a method used to compute the rate of change of a function f(x) with respect to its input x. What is the related rates objective? The objective is to determine the rate of maximum and minimum cost of the given function. The value changes with respect to the surface are to find the cost of function. The related rates applied in this method is implicit differentiation and chain rule differentiation. Now, let's take a look at the situation related to the application of differentiation.
Hi, Diba. What are you doing? Oh, I'm just going to store. Oh, Aisha, where did you buy the bottle? I buy this from Kevin in KL.
Diba, my bottle is very dirty. Do you know a place to polish my bottle?
Oh, I know that one place.
Oh, where? Oh, is it expensive?
Not really.
Oh.
It just looks nice.
Diba, have you ever thought about how to relate the cost of polishing this bottle with differentiation application in calculus?
Oh, I know how to get the cost of polishing water with differentiation.
Oh, how?
Hi guys, what are you doing? Oh, we are discussing about this. What's wrong? We are having problem to solve this question.
Let us to show how to solve the problem. We are now gonna have a look at the differentiation but in more practical context. So the question say a solid water cylinder which is used in an expensive laser amplifier has a volume of 75 pi centimeter cube. The cost of polishing the surface area of this water cylinder is 2 ringgit per centimeter square and 3 ringgit per centimeter square for the circular top and base area, given that the radius of the cylinder is rcm. First, show that the cost of the polishing C ringgit is given by C equal to 6 pi r square plus 300 pi over r. Second, use calculus to find the minimum cost of the polishing. And lastly, justify the answer that you have obtained in part B is a minimum.
Well, let's first of all draw the situation, so just a rough diagram of a cylinder. So it told us that the radius, and here we got the head, so it told us the cylinder has a volume of 75 pi centimeter cube. Let's write in math. So this is part A we're doing now. So we are told that the volume is 75 pi, which is pi r squared times h, and rather that equal to 75 pi. Then it told us that the cost of the polishing the surface area of this water cylinder is 2 ringgit per centimeter square and 3 ringgit for the circular top and base area, given that the radius of the cylinder is r centimeters. Sure that the cost of polishing C ringgit is given by that there. Let's first of all look at the curved surface area. So curved area is equal to 2 pi rh. So the cost that will choose is 2 ringgit per centimeter square will be 2 times 2 pi rh equal 4 pi rh. The top and base is 2 pi r square and the cost is 3 ringgit, so 3 times 2 pi r square equals 6 pi r square. So add them together, the cost C equals, we've got 6 pi r square plus 4 pi rh. So notice that the 6 pi r is in the formula, but 4 pi rh is not in the formula. Somehow, this here we got transferred that it is equal to 300 pi over r. So look at the diagram of the cylinder. Under this we'll write a little bit of information that pi r square h or 75 pi. Given the information we had the form the question What we'll go to now is rearrange this to find out what h equals so that we can eliminate h from this question. So h equals 75 pi over pi r square equals 75 over r square. So we can say that this is equal to 6 pi r square plus 4 pi r times h, which is h is 75 over r square equals 6 pi r square plus 4 times 75 is 300. So plus 300 pi r over r square equals 6 pi r square. Do a little bit of cancelling. One of those r cancel with that r, so plus 300 pi over r as we were asked to show in the question.
Use calculus to find the minimum cost of polishing. Give your answer to the nearest RM. From this part, we gonna rewrite r over r to the minus 1. So differentiating that to find a minimum, we were differentiate dc by dr equals. So we were differentiating that our now so become 12 pi r times by the power which is take 1 from the power which equals r to the 1. So now time by the power again, so that become minus 300 by r to the minus power 2, which at the stationary point at this form of equation here is brilliant for differentiating. However, it absolutely terrible for solving equations, so makes sense to put this back into the original fractional from the rather than having negative power, so we were solving it best to put in the ordinary index form not negative power, so make 300 pi not the 2 but over r squared equals 0. And Hoover now is 2 times r by r squared times everything by r squared to get 12 pi r cubed minus 300 pi equals 0. If I divide everything by pi, they are disappear, which means that r 12 r cubed minus 300 equals 0. Dividing by 12 now, so r cubed equal 25, which means that r cubed the cube root of 25, and the substituent it back in the formula of cost, we get that the total cost of polishing of is 6 pi times the cube root of 25 equal plus 300 pi cube of 25 in the minus 1. Approximate equal leads to 480 ringgit.
Justify that the answer that you have obtained in part B is a minimum. First, d square c divided by dr square equals to 12 pi plus 600 pi r powered by minus 3. We are going to sub in the value for r, 12 pi plus 600 pi, cube root of 25 to the minus 3. Now, clearly this is going to be positive, however we do actually need to get the mark. So it's equal to 36 pi, which is greater than 0. Therefore, a minimum.
For the summary, we can identify the right formula. The derivative correctly will lead a solid answer, a maximum or minimum cost.